Wow, look at that. Hello everyone, and welcome to our course on PlayStation programming, or PS1 programming, or PSX programming, however you want to call it, right? The original PlayStation, that console that was released in 1994 and basically exploded and got everyone's attention, and let's face it, right? Everyone loves the PlayStation. My name is Gustavo Pezzi. I teach computer science and mathematics here in the UK, and I am super happy that I'm able to bring this course to our school. The PlayStation brings a lot of technology milestones, right? Change in the way that we think about programming games. You will see that we moved from a CISC processor to something called a RISC processor, so that is also a big change. We're going to cover that as well in our course. You're going to see that differently than the other retro consoles that we cover in the school. In this generation, we are sitting in that era where we start coding using a high-level programming language, so we are not going to cover only using assembler and assembly language. We are actually going to use the C programming language, right? So this is pretty much one of the first generations that we were able to do that, right? We have a little bit of wiggle room in terms of processing power, and we can use a high-level programming language, C, to develop games for the PlayStation. This means that we're going to cover a lot of technology in terms of the way that we approach programming games, the way that we develop assets, textures, 3D models. We now have a CD-ROM that we can read instructions and read assets from. So now we have this CD subsystem that we have to control and we have to program as well. We have this powerful RISC CPU that we need to learn how to tame. We have powerful audio capabilities, and at the heart of everything, we have 3D polygons, right? We have the ability of pushing fast polygons to the screen, which was basically the main goal of the PlayStation as it entered the market in 1994. And this course is going to be a little bit unorthodox, a little bit different than the others, because different than what most people do, we are going to actually start learning MIPS assembler, right? So we're going to actually look at the CPU, we're going to understand the architecture of the CPU, how the CPU orchestrates everything in the PlayStation console, and we're going to use, right, really low-level MIPS assembler. We might not be masters in MIPS assembler at the end, but I just want to use MIPS assembler because using assembly language allows us to really pay attention to the details, right, understand why this RISC CPU was such a game changer, right? And this 5th generation of 32-bit consoles. So we are going to start with MIPS assembler. And you will see, this generation, as I mentioned, we are going to use a high-level programming language, right? To be productive, to actually get more stuff done, and to really take the advantage of using a compiler, right? We are going to use the C programming language after that to actually get some productivity, get some stuff out of the door, right? Create our games, we're going to use the C programming language. Of course, we're going to use the C programming language with the SciQ library, which is the official old-school Sony library that they gave to developers to program, right? So we're going to have this SciQ set of header files, C files, we're going to have all these data structures, all these types that we can use, which comes from the original SciQ Sony PS1 SDK, right? The development kit for the PlayStation. Right, so let's just look at the bird's eye view of what we're going to cover, because we have a lot to cover. So we're going to look first into a little bit of the history of the PS1. So what were the business motivations, what were the technology motivations that led to the development of the PS1 in the first place? And then after that, we're going to break the PS1 apart. We're going to look at the hardware, right? We're going to look at the motherboard, we're going to look at the CD subsystem, the CPU, the processor, the GPU, the co-processors that we have inside the CPU. So there's a lot of important knowledge that we can learn from whenever we look at the hardware of the PS1. And after that, we're going to start learning how to instruct the CPU, and for that, we're going to use MIPS assembler, right? We're going to use a little assembler that we're going to go write our assembly language, and we're going to start poking the bits of the CPU to make things happen, right? To send values to the display, to draw polygons on the screen, to emit sound, to control the CD. So all these things, all these little chunks of knowledge, I want to do them using assembly language. Because once we understand the architecture of the CPU, how to program for the PlayStation using these really low-level ideas of using an assembler, right? Using assembly language, instruction per instruction, then it's going to be super easy for us to go and start moving to a high-level language, right? Using a C compiler, just using the C programming language to do exactly what we were doing before, but faster, right? So that is exactly what I want to do. This is going to be the flow of our course. First, assembly language, just touch and go so we understand a little bit how these things work under the hood. And then after that, we really are going to start using a C compiler. We're going to use this official Sony SDK, right? The SciQ library provided by Sony and Psygnosis. And we're going to start learning, right? Line by line, how to use these libraries to tell the PlayStation what to do. And just to give you a spoiler already, we're going to cover things like graphics, right? Graphics is a super big topic that has an umbrella of subtopics inside, so we're going to be able to draw triangles on the screen, different shading triangles, Gora shaded triangles, flat shaded triangles, textured triangles, texture quads, so we have different primitives and different types of polygons that we can render with the PlayStation, right? We're going to talk about something called ordering tables, we're going to talk about this GPU instructions and GPU commands that we have to emit in order to draw these things and rasterize these things on our CRT display. And while we are talking about 3D, we have to talk about a super important coprocessor called the GTE, the Geometry Transformation Engine. We are going to understand what the GTE does. We're going to look at the actual assembly instructions that are required for us to use this coprocessor to perform vector math, matrix math, transformations, rotation, projection. So the GTE coprocessor is super, super important. We're going to take a deep look at the GPE and really understand how to take the power of this coprocessor. And we're also going to look at, of course, joypad input, because we have to use the controllers to go left, right, up and down, cross, square, circle, triangle. So all those options that the controller of the PlayStation brought to the table, we're going to learn how they work in both assembly and C. And after we learn controllers, we're going to talk also about proper gaming programming patterns, right? Because as you will see, we don't have floating point numbers. We're going to have to find another way of creating movement, controlling this fractional part of numbers. So we're going to learn about fixed point math. So that is another topic, a huge topic that we're going to cover in our course. And once we are done learning all these small chunks of information, right? GTE, fixed point math, GPU, audio, all these small examples and small details, at the end, what I want to do is, for us to really consolidate our knowledge, we are going to tackle a bigger project. So we're going to glue everything together with a proper game, right? I want to create a proper demo, a proper game, something that you have enemies, something that you have several polygons on the screen, something that we can actually manipulate, all these pieces of the puzzle, right? The GTE, the audio, fixed point mathematics, GPU, controller input. So all these things, we have to start working and putting all these things together into a proper game, right? Using the C programming language for that at the end. So hopefully you are on board with my plan. You will see, this is just a bird's eye view of what we're going to cover. There is a lot more that we have to cover. Every topic opens a new topic, but trust me, this is super, super fun, right? I am so happy that we are actually able to start this journey together. You will see, at the end of our course, the end result and everything that you will learn is nothing but amazing. And not just the final result, as you will see, we are going to learn several important computer science topics. Like we're going to talk about data structures, we're going to talk about algorithms, we're going to talk about performance, we're going to talk about squeezing assets to fit in a CD-ROM. There are so many topics that we're going to cover in this course that are basically part of the computer science curriculum that I think if you complete this course, you will be more than ready to create your own PlayStation games. I guarantee it. Oh, and super quick, people usually ask me, Gustavo, what is the tool chain that you're going to have to install in my machine to have fun, right, with everyone else? Look, the original Sony library was a 32-bit Windows library, right? So back in the day, it was required for us to have either like Windows 95 or Windows XP to use the original libraries, right? So you can go the hardcore route and install Windows 95 or Windows XP to actually use the 32-bit libraries. And I might actually do that in my machine. But most students, they are more comfortable using a modern toolchain. So a modern compiler using Visual Studio Code on Windows 11, Windows 10. So you have that option of using a modern compiler, a modern toolchain. The community developed several tools for us to actually take advantage of these modern compilers and modern toolchains and modern debuggers. So you can use that as well. So you have two options. You can either go the old school way and install Windows XP and use the original Sony SciQ library and all those files, right, the binaries that we use for Windows XP, or you can take advantage of a modern Windows machine, a 64-bit Windows machine. Then you can use a modern C compiler, a modern C debugger, you can use a text editor, you can use Visual Studio Code. Most students like that option, right? Like they like that alternative of using a modern compiler. Again, you are free to do whatever you want. The question also, right, Gustavo, so if I have a MacBook Pro, or if I use macOS, or if I use FreeBSD or Linux, does that mean that I cannot enjoy the course and take the course? No, you can enjoy the course, but we're going to have to probably install a virtual box or install an emulation that has Windows for that, right? So it is pretty much a requirement for us to use Windows. You're just going to have to find an alternative, right? Virtual box or an emulator or something that allows us to use either the old school Windows XP or a modern Windows 11 with this modern SDK, all these options with a modern compiler in your machine, right? So this is the toolchain. Very well, so look, this is what I wanted to briefly cover. I just wanted to give you an idea of what are the topics that we're going to cover. There's a lot that we have to dissect and learn. You're going to have quizzes, you're going to have exercises. You can, of course, discuss with other students in the discussion board for each lecture. So this is a very well-structured course that I created. I'm really, really proud of all the journey that is going to take us from basically zero to competent PlayStation programmers, right, in this short period of time. So hopefully you agree with the path that we're going to take, and there is nothing else for us to do but to start now. So welcome to the school. I'll see you inside.